All right, so we're going to talk about Module 9 in this video, which is on sections 11.3, 11.4, and 11.5. We're going to talk about average, standard deviation, variance, and then we'll also talk about some percentiles and some quartiles. So let's just start by talking about measures of average, which is 12.3. And when you hear the word average, a lot of times people assume that the person is talking about mean, because that's probably the most common understanding of what average means. But there are 4 different types of measures of average that we're going to talk about. So mean, median, mode, and mid-range. So let's start by talking about the mean. So that's probably the most common measure of average. And the mean is just the sum, which just means to add the sum of the values in a data set divided by the number of values. This symbol here is called sigma, and it just means sum. So this top part means add up all the values and divide by the number of values. Okay, if this math, if the way this is written math-wise doesn't make sense to you, then you don't have to write it like this. You can just think of it as add up all the values divided by the total number of values. So let's look at the first example. So in 2003, there were 12 inmates on death row who were proven innocent and freed. And then in the 5 years after that, there were 6, 2, 1, 3, and 4. And we want to find the mean number of death row inmates proven for the 6 years. So we want to use all of those numbers. So 12, 6, 2, 1, 3, and 4. And if we want to find the mean, we're just going to add those all up. So we're just finding the sum on the top. So the sum of all the values divided by the number of values. And so there are 1, 2, 3, 4, 5, 6 numbers. So we're going to divide by 6. So we end up getting 2.8 divided by 6. And with all of these problems in Connect, just like any other module, you just want to make sure that you pay attention to the directions in terms of rounding. So let's say, this doesn't say in the problem, but let's say we're going to round to 1 decimal place. Okay, so if we divide this, we end up getting approximately 4.7 for our average. Okay, so that was pretty straightforward. We're going to go on to the next one, which is a little bit less straightforward. So what happens if you have group data? So let's talk about what group data is. Let's say you have, we're going to look at this frequency chart down below, and this is, it's asking us to find the mean price of GM stock for the first 74 days of trading. So what this means, you've got some classes here on the left-hand side, and what this means, let's talk about what these classes are and how to interpret this. So let's look at this class right here. So what this means is we have, we've just organized the data into groups, okay? And you'll never have to actually make the groups will be given for you. And so this group, this is stock price of $1.51 to $2. And this 18 tells us that there are 18, okay, different stocks that are between $1.51 and $2, or there are 14 stocks that are between $2.01 and $2.50. There are 16 stocks between $2.51 and $3. The problem is we don't know the actual numbers of each individual stock. So sure, we know that there are 18 in that range, but we could have all 18 at $2, or we could have 18 stocks at $1.52, or they could all be different numbers. We don't know, we just know they're in their range. So what we're going to do is we're going to make an educated guess. And the best way to do that is just to take what's called the midpoint of each class. So let's look at this first class, $1 and a cent, so 1.01 to $1.50. We're going to find the very middle of that class by adding up those two numbers and dividing by 2. Okay, that's going to give us that midpoint of the class. So you can see that work right here. 1.01 plus 150 divided by 2, and we're going to find that midpoint is 1.255. That's the number that's directly in between $1, 1.01, and 1.5. Okay, and then we're going to say, okay, well, we have, that's the approximate value in between that range, and then we're going to multiply it by the frequency because we have one number in that range. So that number times 1 is just 1.255, and we're going to list that here, okay? So let's do it again for the next row. Okay, I'm just going to erase this real quick. We're going to find the midpoint of the class. So the class is here, 1.51 plus 2 divided by 2. We're always dividing by 2. We're taking the two values, adding them together, and dividing by 2 to find the middle, and we get 1.755. Okay, and we have 18 of those. So notice the frequency. There are 18 of those numbers in between that range. So we're going to take 1.755 times 18 is 3159. And really what we're doing is we're just taking the mean. Above, you saw me add up all those numbers. When you multiply something by 18, it's like you're adding 1.755 to itself 18 times. So the multiplication is just a shortcut, so we don't have to add up all these numbers since it's a long list. All right, so let's do the next class. So we're on to this class. So 2.01 plus 250 divided by 2 gives us 2.255, and then we're going to take that number and we're going to divide by the frequency, which is 14 in this case, and we get 31.57. Okay, on to the next class. 2.51 plus $3 divided by 2 is equal to 2.755. Okay, 2.755 times 16, because 16, we have 16 of those in this class, 44.08. All right, next class. And this would actually be a really good opportunity. You could even pause this video and finish this yourself, and then double check your work instead of just watching it from the beginning, but you know, do whatever works for you. So 3.255, so 3.255 times the frequency, which is 12, and 3906. All right, and then we've got the next class. So 3.51 plus 4 divided by 2 equals 3.755. 3.755 times the frequency, which is 8, is going to give us 30.04. And then last but not least, we've got the 4.01 plus 450 divided by 2 equals 4.255. And then we're going to take that number and multiply it by the frequency, which is 5, and we get 21.275. Okay, I'm just going to double check all those numbers real quick. I've got my answer key next to me, and those all look good. So you can see here, there's so much computation, so many computations involved in these problems. I think, you know, my biggest piece of advice with all of the problems in this module is just to really take your time and double check your work, because even if you're doing all the steps right, if you make even one error in the computation, then it's going to throw the answer off. Okay, so now what we want to do, just like above when we found the mean, what do? We found the sum, okay, of everything. So to find the sum, we're going to add all these up. So we're going to find the sum of these. So we're going to add up all of these numbers here. Okay, and if we add those up, I got 198.87, and we're going to divide by the total. So the mean, which we call x bar, that's the notation, I should have mentioned that earlier, we're going to take the sum of all the numbers, that's what that x stands for, and divide by the total of numbers. So in this case, our sum is 198.87 divided by, well, let's think about this, what n should be. So what is the total number of values? Well, the frequency column tells us the number in each class. So if we add up all of those numbers in the frequency column, that will give us our n. And if we do that, we get 74. So in that case, that's our n. That's the total number of values we have. So if we take 198.87 and divide by 74, we get, if we round to 2 decimal places, 2.69. And that's the average price of stock. And I want you to think about this when you get answers to these questions. I mean, look at the frequency chart and kind of step back. So look at these numbers right here and ask yourself, okay, does $2.69, does that make sense in terms of the average? Well, 269 would fall about right in here. And if you look, that's the middle of our list. So our numbers start at $1.01 all the way up to $4.50. So 269 seems like a reasonable average. If you'd gotten an average like, I don't know, $7 and something, you could look at this list and say, well, that doesn't make sense at all because none of them are in the $7 range. So that's a good way to just check your answer and catch yourself if you make a mistake. All right, so we're going to move on to the next measure of average, which is the median. So the median is the halfway point, okay, which is basically just the middle. Okay, but the most important part here is that the data has to be in order. If the data is just, if you just have a list of numbers in any order and you tell somebody, well, this is the middle number, that doesn't mean anything. It's got to be in order. So that's the thing that you really want to make sure that you remember, because sometimes you get going on your homework quickly and it's easy to just forget to order and then you'll get it wrong. So let's look at the next example. So we're going to put these numbers in order. So I'm going to go ahead and order these. Okay, and you can use this list is short, so it's not bad in terms of ordering, but you can use Excel if you want, if you're familiar with Excel and you have that on your computer. You could use Excel to order the numbers in the homework. You could certainly use your graphing calculator. You know what I will do real quick is I'll show you, I'm just going to pull up my graphing calculator in case you have one, and I'll show you how to order numbers with it. You're going to press the Stat button and then Enter. And then you can type in all of your numbers. So I'm going to type in 345 and 340 and 315 and 285 and 317. Okay, and then I'm going to hit Stat, go down to Sort A, that stands for Sort Ascending, which means least to greatest. Hit Enter, and then you have to tell the calculator what list to sort. Now I put all of my numbers into L1, so you'll notice there's an L1 above the 1 key, so just hit second, 1, and then Enter. And then if we go back to the list, so Stat, Enter, all of those numbers will be in order. So, and again, this is a short list. You would never probably even use a calculator to do this list, but on the homework there's some longer ones, so this could be helpful. And if you don't have a graphing calculator, this is totally not necessary. It's just, it's helpful if here's some instructions if you do. So let's move on to the next example. Or no, I'm sorry, we never finished this one. So we put it in order, and now we want to find the middle. So one way to find the middle is just to kind of start on the outsides and work your way in, and then identify what number's in the middle. So in this example, we have a clear middle. The median is 317. In the next example, it's not, we don't have a clear middle. So let me go ahead. I'm going to order these first. All right, so we're going to work from the outside in. So we're going to, and you can use your fingers if you want. So you just work one at a time to get the middle. And then we notice that there are two numbers that are in the center. And anytime you have an even number of numbers, this is going to happen. And so if you have a tie for the middle, what you want to do is find the number that's in the middle of those numbers. So you're going to do the same thing you did with the group data when we found the midpoint. We're going to add them and divide by 2. So 1700 plus 1751 divided by 2, and we get 1725.5. So that's going to be the median. Okay, so two different ways to find the median depending on how many numbers are on the list. You put them in order, and if you find the middle, if there's not an exact middle, you add the 2 up that are in the middle and divide by 2. Okay, now let's talk about the mode. So the mode is the value that occurs most often. This doesn't necessarily mean that every single repeating value is going to be the mode, because just because a value occurs more than once doesn't make it a mode. It has to occur the most. Okay, sometimes it's possible to have more than one mode. It's possible to have no mode if there aren't any values that repeat. So let's look at this next example. So in this example, we have a couple of numbers that repeat. So I'm noticing that 10 repeats, I'm noticing that 12 repeats, I'm noticing that 13 repeats, and I'm noticing that 15 repeats. So it looks like 10 repeats 3 times. I'm just going to use tally marks here. It looks like 11 repeats. Oh, I didn't list 11, it repeats once. So it's looking that 12 repeats 1, 2, 3, 4 times. It's looking that 13 repeats 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, and then it looks like 15 repeats. We've got 1, 2, 3, and 4 times. Okay, so it looks like 13 is going to be our mode because it repeats the most. And we're not going to list the other ones. Even though they repeat, they don't repeat as much as 13, so they're not listed. The next example shows you an example where there would be no mode because every value only occurs one time. So on Connect, you'll be first asked, is there a mode? And you'll say yes or no. And then if you say yes, then they'll prompt you to put in the values. All right, let's look at the next one. So we've done one mode, we've done no mode. Let's look at one where this one has more than one mode here. So it looks like 4 repeats. So 4 repeats 1, 2, 3 times, and 8 repeats 1, 2, 3 times. So since they both repeat 3 times, we're going to say the modes, there are 2, are 4 and 8. Okay. Let's go down to, let's do one more with mode. Let's talk about, this has to do with categorical data. So in this case, we're given a survey of the junior class at Fiesta State University, and it shows the following students majoring in each field. Find the mode. Basically what this is asking is it's saying which major has the most students, because that's what mode means. So it's, in this case, you look at this a little bit differently. You're not going to look at, I mean, if you notice each of these numbers, none of them repeat. That's not what we're being asked here. If you think about what these numbers mean, so there were 1,425 students who all selected business. So imagine what that list looks like. You're going to see business and business and business and business 1,425 times. That's going to be our mode because it occurs the most. And it's categorical data because, you know, we have these set categories associated with the number. So I think, you know, hopefully you'll be able to spot this easily in the homework because each of these numbers actually have a category attached to them. So you'll approach it this way when you have a problem like that. All right, so let's, we're going to do the last one. So the last one is called mid-range, and we've actually already done this before. So mid-range is really quick, which is nice. So mid-range. It's very quick. It's a rough estimate of the middle, and you just have to take the lowest and the highest value and divide by 2. So let's do an example. So we have this example from before, same one that we done with the death row inmates proven innocent, and we've got these numbers, okay, and we want to find the lowest plus the highest and divide by 2. So it looks like the lowest is going to be 1 and the highest is 12. So we get 13 divided by 2, which is 6.5. Okay, so, you know, overall, I think all of these are helpful. They all have their pros and cons. For example, the mid-range is very quick, but, you know, you're only looking at the lowest and highest. You're not looking at all the values in the middle. I'm just going to scroll up here. Mode is also, can be quick. It depends how long the list is. It can be helpful if you're in a situation where you want to know how many, like the greatest frequency, like for instance, if you're surveying a bunch of students in college and you want to know how many select each major. Median is nice because it can tell us the center, but it's also, and this is a pro and con, it's resistant to outliers, outliers being high and low values. So if you think about, if we find the middle, these values on the end, they could be anything. I mean, this high value here, that could be 1,000,000 and it's not going to affect the median or the middle. Whereas mean, I'll scroll up, lastly, mean is going to take into account all the values, which is good in some instances, and it can be bad if you have a really big outlier that you don't want factored in. So, you know, I think all of these are good. No one measure of central tendency is better than the other. I think it's just nice to have some different options and sometimes even use them together. So let's talk about 11.4, which is the next section, and it talks about measures of variation. And variation just means how, I'm just going to talk about that first. So how much does the data vary? So how much is it spread out? Are the values close together? Are they far apart? And the simplest measure of variation is the range. And the range is just the highest minus the lowest value. So super simple. So let's look at this example here. So we're asked to, we've got the list of weights of dogs, okay, in two pictures. And we're asked to find the mean and the range. So for number 1, okay, the mean, if you add those up and divide by the total, I'm just going to write down the answer. Feel free to pause the video and calculate it if you want more practice. Is 65.25 pounds. Okay, for the second example, the mean is 64 pounds. Okay, so the averages are really close. Let's find the range. So for the first list, we're going to take the high minus the low. So the highest value looks like 73 and the lowest is 58. So 73 minus 58, we get 15 pounds. Okay, so that's the range for the first one. And the range for the second one, we're looking at highest. So we've got 125 minus the lowest, which is 30. And the range is 95 pounds. So here's an example where you've got means that are really similar. Okay, so that tells us, you know, that you could look at those numbers if you didn't have the range and think, oh, well, the dogs in both these pictures, they were pretty similar. But the range tells us a different picture. So the range tells us that this first set of dogs, that their weights were pretty similar to each other. They didn't vary very much. Whereas the second set of dogs, the weights, there was a lot more variation. So a lot more variation, which just means they were spread out with that second picture. So it's kind of nice to have the range there because the mean wouldn't have told us that whole picture. All right, so that's, I would say, the easiest way to determine some variation. Next, we're going to talk about variance and standard deviation, which is a little bit more complex. So sometimes if there's just one unusually high value or low value, then the range will make it look like there's a lot more variation than there actually is. For example, you know, maybe you have a list of numbers like, I don't know, 48, 49, 50, and then you have, I don't know, 500. Okay, so those are your numbers. And maybe you have a second list, 48, 49, 50, and 51. So I would say those lists are pretty similar, okay, except that this first list has a really, really high value. So if you think about what that range would look like, it's 500 minus 48, okay, whereas the range in the second one is going to be 51 minus 48. Okay, so in this case, we're looking at 452 as the range, and the second one, we're looking at 3. So we have two lists of numbers that are pretty similar, but this high value, this outlier, really throws that range off. So for this reason, we're going to study variance and standard deviation to help us gain another couple of statistics that we can use to describe the data. So let's first talk about variance. So the variance for the data set, and this is kind of a mouthful, but we'll talk about it and then do an example. It's the approximate average of the square of the distance between each value and the mean, okay? And the standard deviation is the square root of the variance. So I would say the simplest way to think of standard deviation, okay, is just how a typical value varies from the mean. It tells you how spread out the data is. So large standard deviations means big spread. The data is really spread out. Smaller standard deviations means there's a smaller spread in the data. So let's go through and do an example, and then we'll talk about what these means. So you've got steps here on the side. If you want, you could pause the video and try to follow those steps and do it, or you could watch along first and then try to do it, whatever works best. So we've got some heights here for the Cleveland Cavalier scorers, okay, basketball players here, and we're going to find the variance and standard deviation. So step one is to find the mean. So if you add all of these up and you divide by 6, you end up getting a mean of 78.5 inches. So again, we're just going to add up all those values and divide by 6, and you should get mean of 78.5. Next step is, so step 2 is you're going to subtract the mean from the data values. So I list all the data values here in this table. I would highly recommend when you do this in your homework, make a table like this for yourself. So we're going to take the data value 80 minus the mean 78.5. Okay, and we get 1.5. Next, data value 73 minus 78.5, which is our mean, negative 5.5. Data value minus the mean, data value, data value, and then we'll do one more here. And then we've got our last data value, so 74 minus 78.5 equals negative 4.5, okay? So you'll notice some of them are positive, some are negative. In this next column, so we're on step 3, so this is step 3, okay? And this is step 2, and then the mean was step 1. Okay, the next thing we're going to do is we're going to square these, and it's really, really important that if you use your calculator, which you probably will, that you put these in parentheses, because the result here is always positive. And let me just show you real quick. If you fail to put parentheses, so let's take negative 4.5 squared for instance. If you don't put parentheses, so let me just clear my screen here. If you don't put parentheses, if you just do negative 4.5 squared, you'll end up getting a negative number, which is not correct. So you have to use parentheses, negative 4.5, end parenthesis, and you should get a positive number, which is correct. Or you could just remember to always make sure that these numbers here are positive. So I'm just going to go ahead and write down all the answers from squaring these. And again, just like the other problems, lots of computations here. So it's really important you just keep yourself organized and you take your time when you add all of these up and square. So the next step, step 4, is you're going to take the sum of the squares. So you're going to add up this column here. So you're going to find the sum of those numbers. This should also be positive because all of these numbers are positive. So we take the sum. Okay, so this is step 4, okay. Step 5 is we're going to divide. So step 5 is we're going to divide 165.5 divided by n minus 1, okay. Let's, in this case, n is going to be 1, 2, 3, 4, 5, 6, so our n is 6 because there's 6 data values here. So 6 minus 1 is 5, so we're going to divide by 5. So that's going to be our step 5, and that's going to be our variance. So our variance, if we divide those two numbers, is 33.1, okay. The next step, so the last step, step 6, is we're going to take the square root of the variance, so square root of 33.1, and that's going to give us our standard deviation. So our standard deviation is 5.75 inches. So if you want to, I know this goes beyond what this lesson calls for, but just a quick picture, and we'll talk about this more in Module 10 because we'll talk about the normal curve. But if your average height for these players is 78.5, so I'm going to put that in the middle of this curve, this standard deviation of 5.5 means that on either side of 78.5, if we were to add 5.5 inches, or I'm sorry, 5.75, or subtract 5.75, that's the range that most of these players are going to be in. Okay, I would say it's a fairly small standard deviation, so it means that these players' heights are going to be relatively close to that 78.5 average, which I would say is what you would expect with some professional basketball players. You're not going to get a whole lot of variation there because most of them are going to be tall. All right, so let's look at this next example. So we're not going to calculate anything. We're just going to talk about what it means. So a professor has 2 sections of Math 115. Okay, so we have this 8:30 a.m. class. I'm just going to say the morning class, 8:30 a.m. has a mean of 74, standard deviation of 3.6. The 2 p.m. class has a mean of 74, so same mean. So if you had the means, you would think, okay, well, they scored the exact same, but not so fast. That class has a standard deviation of 9.2. What can you conclude about the students' averages in these sections? Okay, so I would say, like in this first section, the standard deviation is a lot smaller than it is for the second class. So I would say most students probably scored around 74. Okay, so less variation than the afternoon class. Okay, in the afternoon class, I would say scores are going to vary more compared to the morning class. So even though the average is 74, I mean, you could get students who maybe scored 100 and maybe scored, I don't know, 30%, and they're going to be all in between, but when you average them out, they end up averaging to 74. So there's much more variation or differences in the scores in the, or spread, I should say, in that second class compared to the morning class. So that concludes section 11.4. We've got one more section to do, 11.5, and this has to do with measures of position. And we're going to start by talking about percentile. So a percentile just describes where a data value is compared to the rest of the values. So you may remember, or maybe not, when you went to the doctor when you were little, or if you have little kids, you might be able to reference this, but a lot of times the doctor will give you a percentile for your weight and height. So for example, if I was told that I was 70th percentile for height, what that means, if this is me, it means that I am taller than 70% of people. So 70% of people are shorter than me. And 30%, because 70 plus 30 is 100, are taller. So it means that, you know, I'm fairly tall. So the percentile always describes the percentage that is below you. Okay. So let's look at this example, and then we'll come up and we'll use this formula. So it says, suppose you score 77 on a test in a class of 10 people with 10 scores listed below. What was your percentile rank? Okay, so the first thing that I'm going to do is I'm going to order these numbers. So that's really important. So order numbers first. Okay, do it by hand. You could use your calculator. So 52, 64, 71, 75, and I already have this done on my answer key. So that's why it's going fast for me. So all right, so we've got the list of scores in order, so we can just ignore this first list here and look at my list. And I'm going to identify where I am. So I am score 77, okay? So this is me, and I want to know my percentile rank. So when you want to find percentile rank, you're going to use this formula here. You're going to figure out how many scores are below X, which means below you, the value that you're looking at. So let's calculate that, or count that. So if this is me, there are 1, 2, 3, 4 scores below. Okay. divided by the total. So there are 10 people in the class, so 4 divided by 10 and then times 100 since I'm looking for a percent, and I end up getting 40. So I'm in the 40th percentile, which means there are 40% of people that scored below me, and 100 minus 40 is 60, so that means there's 60% above me. So it means I did not do so well on that test. Okay. Let's look at the next example. So the number of words in each of the last 10 presidential inaugural addresses is listed below. So find the length that corresponds to the 30th percentile. So this is a different type of problem. The first one we were asked to find the percentile. Now we're given the percentile, but we're asked to find the value. So the first thing we're going to do is we're going to put these in order. Okay, and then we're going to figure out, well, what would 30% be? So we're going to take the percentile as a decimal, okay, and we're going to multiply that by the number of values. Okay, so the percentile is 30, so 30 is 0.30 as a decimal, times the number of values, which is 10, and we get 3. So there are 3 scores below, okay, that's the important part, the score we're trying to find. So the score we're looking for. So what score has 3 below it? Well, score 1,668. Well, and I shouldn't say score, number. Okay, so 1668 has 3 numbers below. So it means that 1668 is the 30th percentile. Okay. All right, so last example with percentiles. So, and you should find, hopefully all of your homework questions relate to one of these. So in this case, we've got two students competing for one remaining spot in law school class. So they want to figure out basically who's better, who scores better. Miguel ranked 51st in a class of 1,700. So I'm just going to write that down. So Miguel is ranked 51st out of 1,700, and then Dustin ranked 27th out of 540. Who did better? So rank is different than percentile rank. So rank is your position from the top. So rank is position from the top. It's kind of like your place, like if you were in a race. Miguel ranked 51st, it means he came 51st out of the 1,700. Dustin came in 27th place. And you might think, well, why do I have to do any math? If Dustin came in 27th place, then didn't he do better? Well, it's hard to say that because there were different amounts of people in the race, so it's hard to compare. So one way we can compare is we can find the percentile. Okay, so to find the percentiles for both of these, we're going to find, and I'm just going to write this down here. So for percentile, we're going to find the number below that person and divide by the total. Okay, so if we want to know how many people were below Miguel, if he was 51st out of 1,700, we're going to take 1,700 and subtract 51. Okay, that gives us the number below him. And we're going to divide by the total, which is 1,700. And if we do that, we get 0.97, which you can multiply that by 100 to get 97th percentile. So he was 97th percentile. For Dustin, if you want to know, if he was 27th place, we're going to take the total people minus 27. That gives you the number of people below him divided by the total, which is 540. And you get 0.95, which is equivalent to the 95th percentile. Okay, and in terms of percentile, the higher the percentile, the better it is if they're wanting to be at the top here. So I would say that Miguel did better because his percentile is higher. So lastly, let's talk about, well, almost last, we're going to do box and whiskers plots too, but we're going to talk about quartiles. So a quartile divides the data set into quarters. And if you think, I'll just draw you a simple picture. Imagine for a minute that you have a rectangular birthday cake and you want to divide it into 4 evenly sliced rectangular pieces. What you could do is you could divide it in half, and then you could divide each of those halves in half, and that would make 1, 2, 3, 4 equal pieces, which are called quarters. The quartiles are going to be the values, so this where we're dividing. So 3 quartiles give you 4 slices of cake. Okay, so 3 quartiles, 4 slices of cake. So in this case, we're going to find 3 quartiles to have 4 sections of numbers. Okay, so the second quartile, which is this one right here, that's the same thing as the median. Okay, so that's the median, which is also called Q2. So the median is Q2. Okay, the first quartile is the median of the lower half. It's the 25% of the data fall below it. Okay, so this is Q1 right here, and you've got 25% of data below that number. So that's Q1. And Q3 is called the third quartile, which is right here, and it's the median of the upper half of the data. 75% of the data fall below that because every single one of these pieces of the cake is 25%. Okay, let me just draw, I'm going to draw this picture again here so it's a little bit clearer. So again, you divide it in half. This is your Q2, which is also the median. The median is when you divide a data set in half, when it's in order. Then you divide the lower half in half. That's going to be your Q1. You divide the upper half in half, and that's going to be your Q3 or your upper quartile. Every single one of these sections is 25% of the data. So that's why that Q3 has 75% below it. Q2 has 50 below it, 25 and 25 is 50, and Q1 has 25 below it. Okay, so let's look down here and do this next example. So the very first thing you want to do is put the list in order. So put the list in order, really important. Okay, so I'm just going to write these numbers in order: 14, 20, 21, 24, 35, 36, and 42. Okay, so we've got those in order. And the very first thing you're going to do, so number 1, you're going to find quartile 2, which is the median. You're going to divide the data in half. Okay, so I'm going to start on the outsides and I'm going to work my way in. And I'm going to find the half is between 21 and 24. So since there's a tie here, I'm going to add those up and divide by 2. So 21 plus 24 divided by 2 is equal to 22.5. So that's the Q2, that's the median. The next thing you're going to do, okay, step 2, is you're going to find Q1, which is the middle of the lower half. And you're not going to include the median. Don't include the median or Q2. So that means I'm going to use a different color. I'm only looking at these numbers. I'm not including that 22.5. So you're going to find the middle of that list, which is in between that 14 and 20. Okay, and so since there's a tie there, you're going to add those up and divide by 2. So 14 and 20 divided by 2, you're going to get 17, and that's your Q1. Next, you're going to look at the last step is you're going to look at the upper half, and you're going to find the middle of the upper half of the data. So step 3 is you're going to find Q3, which is the middle of the upper half, not including the median. Okay, so the middle of this is going to be between 35 and 36. So 35 plus 36 divided by 2 is 35.5, and that's going to be your Q3. So in Connect, the problems are going to look identical to this. You're going to have a list of numbers, and basically you're just going to put it in order, find the middle, and then find the middle of the lower and the upper half. Just making sure that whatever you do not include that middle number when you find Q1 and Q3, when finding Q1 and Q3. Cool. All right, hope that helps. So we've got, it looks like, I think we've got one more here. So we've got, let's look at this box plot. So a box plot is a type of graph that summarizes the data set, and it summarizes it in quartiles. So if you look at this box plot, there's 4 sections of the plot. So we've got right here, this, we call that a whisker, this section, and this section. Each section has 25% of the data inside of it. Okay, if one part of the box looks bigger than the other, so for example, like this section of the box looks a little wider, all that means is that there's a wider range of values there. It doesn't mean that there are more values in that section of the box. Okay, so let's look at, I'm just gonna erase this here. We're gonna look at each of the sections of the box and try to pull out some more specific information. So I'm just going to put a dot here. That value, that low end, that tells you the minimum. So if you notice underneath the box is a number line. If you go down and try to read, and I know we're kind of estimating here, it's kind of hard to see. It looks like that's about maybe 11. The highest value, if we come over here, looks like it's about maybe 42. Oh, and you know what? I'm looking at, I just realized this. If we scroll up here, this is a box plot that's summarizing the data set that's above. So that's where I'm getting these numbers too. So if we look at our set above, 11 was our lower value, 42 was our highest. Okay, so 11 is our minimum, 42 is our maximum. We found that our quartile 1 was 17, and that corresponds to this part of the box. So this is our Q1, and we found our Q2, which is the median, is that middle line of the box, and so our median is 22.5, and we found our Q3 was 35.5, which is that this line on the box. Okay, so again, we've got our minimum, our Q1, our Q2, our Q3, and then our maximum, okay, of our data set. And each one of those is a part of that box. And then last but not least, the interquartile range is just the Q3 minus Q1. It's also how big the box is. So if you look at the picture, let me just use a different color. Q1 is right here, Q3 is right here. So if you subtract those two numbers, you're going to find the range in there, and that's the interquartile range. So if we were to subtract those two, I'll just come down here. So Q3 minus Q1 is 35.5 minus 17. We get 18.5 is our interquartile range, and again, that's how big the box is. So I hope that helps. Definitely let me know if you have any questions.